So this is section 9.1. So now, okay. This is going to be weird. This is the first time I've ever used this. So this is all about radian measure. But in order to use radians, we also have to use degrees. So it is mostly going to be dealing with radians and degrees. All right. Now, if we're dealing with radians and degrees, there's a couple different things to think about. We need to be able to understand the difference between unit measurements. It's kind of like when you were growing up, you know, like you wouldn't have measured everything when you were growing up in yards, right? So you wouldn't have just started spouting off like, oh, I'm 2 yards tall or I'm 1 yard tall. You would have learned things in feet. And in order to learn things in feet, you would have had to learn things in inches. So you would have had to be able to go through things in feet and inches and yards because they're different measurements. The same way that centimeters exist, the same way that meters exist, and miles and things like that. So radians and degrees are interchangeable. There are conversions that we can do between those two things. However, sometimes radians are more important, sometimes degrees are more important, okay? But what we're gonna be using these for is the first idea in trigonometry. Now, really what we wanna think about with trigonometry is the measurements of triangles, okay? That's where that tri comes from. So it's really talking about the measurements of triangles. Now, it's not gonna look like that a lot because a lot of the things that we're gonna be doing is gonna be based on a circle. But once we get into that circle, wow, this is tough. Once we get into that circle, I'm gonna show you how you're really using the unit circle as a triangle instead of a circle. This is really hard to write on. So trigonometry really means the measurements in triangles, which is where right triangle trig comes from. So your only exposure to trigonometry so far has been SOHCAHTOA, right? And maybe a little bit of secant, cosecant, cotangent, those kinds of things that we talked about last year. Your only real exposure has been dealing with things like triangles. That's because that's how trigonometry works, okay? Now, once we have dealt with trigonometry, we expand these things when we get to calc. Calc is when we take the trigonometry concepts and we actually expand them to a lot of different applications where we talk about like linear speed. And we can talk about things like angular velocity, and we can talk about vibrations and rotations. So if you've heard things in physics, if you're in physics class right now, if you've heard of linear speed and angular velocity and all that stuff, all of this trig stuff gets applied to those things, okay? So let's just start out with the bare bones basics terms from section 9.1. The first thing is an angle. And hopefully we all remember what an angle is. And an angle is two rays that share an endpoint. So it is two rays that share an endpoint. So obviously we know that these look like this, right? They have a common endpoint and they are going to just go in two different directions. Now remember, they go on forever. In our cases, we are going to be talking about a circle for most, like you remember yesterday I gave you that unit circle, looked like this. Most of the things that we're going to be dealing with are going to be angles based on that unit circle. So we're just going to be talking about angles that look like these, okay? They'll all have the same side right here. That's called the terminal side. We'll get into that in a second. But we're basically just talking about how this angle can work around a triangle, around a circle. But notice if we were to just connect these dots, we have lots of triangles that could pop up in these. That's where that trigonometry aspect comes into play, okay? So with an angle, obviously it has two different sides. One of those sides is called the terminal side. So one of those sides is called the terminal side. Actually, let's start with the other one first. Sorry, if you already wrote that, apologies. So let's start with the initial side. The initial side is this thing right here. I already drew a picture of it at the beginning, but it is the starting position. It's where the angle starts. So this is the starting position of whatever angle you're dealing with. And 99% of the time in this class, it is going to be this spot right here because we're going to be dealing with the unit circle. And if we're dealing with the unit circle, it's going to start here, okay? Then we end with the terminal side. Wow, my handwriting is absolutely atrocious on this. It's even worse than in real life. So the terminal side is where the angle ends. So this is where the angle ends, and it's really talking about the ending position. This thing is hard to use. So it is the ending position, okay? So we have a couple different things. Obviously, if we have our angle, the angle that it starts with, this angle most of the time, because most of our angles are going to have that kind of look to them where they're pointing to the right. This would be called the initial side because this is where it starts, and this would end up being called the terminal side because this is where it ends. So we have our initial side and we have our terminal side. If you remember back to last year, we introduced the concept of this variable called theta. So theta, T-H-E-T-A. This means the exact same thing as x does. So we've just introduced a different variable, and for whatever reason, someone decided that we should use radian, and when you use radians, you should use theta. So when someone decided you should use right triangle trig, you should use theta. Not really sure why, but it's just the change in variable. So I have theta as my angle. The next type of angle that we're going to talk about is a positive angle. And this positive angle means that we are going in a counterclockwise direction. So positive angles move in a counterclockwise direction. So if I look at the unit circle just like this, if I have an angle that goes from here, a positive angle means that the positive angle means that I have just opened my angle counterclockwise. So I've just opened my angle that way, okay? So positive angle just means that we are starting at our initial side here, and then our terminal side is going to be counterclockwise from wherever we're at, okay? The next thing that we have is a negative angle, which obviously those have to exist. If negatives exist, or if positives exist, then negatives also have to exist. And this just means a clockwise angle. So this could be the exact same angle, but it could just mean the angle is opening in a different direction. It means it's opening like this instead. So those two angles share the exact same spot. They're in the exact same location. So if they're in the exact same location, that introduces the idea of something that we talked about last year called coterminal. Coterminal angles are angles that end in the same spot. So this is what coterminal means. Coterminal angles are angles that end in the same spot. Now, if you want to use calculus words for this or trig words for this, you could say angles that have the same initial and terminal side. So it's angles that have the same initial and terminal side. So that just means that they're in the same location. If you're looking at a graph, other than being told, you'd never be able to tell the difference between certain angles and certain degrees and certain things. Okay, so hopefully that makes sense. Hopefully that's a decent idea because that's something that we ran through last year. So it shouldn't be a brand new concept. Okay, the very, very last thing, why does this not change? Tried this 3 times. So the very last thing is a standard angle. So there's lots of vocab that we need to make sure that we know. Actually, this is standard position. And standard position is when the vertex is at the origin and the initial side is the x-axis. So that is exactly what we've been talking about this entire time, where we have a unit circle, the origin. Remember, if a unit circle is being graphed, oh boy. If a unit circle is being graphed, this would be the origin, right? This would be where the origin is located. And then the initial side would be the x-axis, which means that it would, why can I not draw a straight line? Technology is not my friend. So I would be the origin here, and then the initial side would be the x-axis. That's how all of the ones that we've talked about so far have opened up. That's just what we're kind of looking at here, okay? So hopefully that makes sense. Hopefully that's a pretty straightforward idea. Just a couple of things that you really need to make sure that you understand, okay? So basically what I want to do now is I want to just show you what certain ideas or certain things look like, okay? So what those things look like in terms of degrees and in terms of radians, okay? So when we deal with radians and degrees, you have to be comfortable interchanging between both of those things. So in both of those cases, we have 360 degrees, right? In both of those cases, whether this is radians or whether it's degrees, we know that it's going to be 160 total degrees, right? So if we have 160 total degrees, and if we look at this in terms of X and Y axis, we know using degrees is what we've used for our entire lives. So this should not be something that's really too terrible. So if you're dealing with degrees, you know that there are 360 degrees in an entire circle, right? So this would be where 0 degrees is. If I'm starting all of these in standard position would mean that I start, I'm going to draw this in red. It would mean that I start my angle at the origin and I move my way to the right. In standard position, that's where they start. Positive opens this way and negative would open this way. So we have to be comfortable being able to identify these things on a graph. Now, the way that you have to be comfortable with this is you have to know that this would mean that the angle is 0 degrees big. If I start opening this way and move this way, I know that once it gets to the y-axis, that means it's going to be a 90-degree angle. If I continue that on this way, it's going to make it 180 degrees. Again, continue this way, it's going to be 270. And then as we continue this way, it's going to be 360. If we do one full rotation, it's going to be 360 degrees. Now that's old news, right? The new news, or the new stuff that we really have to pay attention to, is the fact that negative angles also exist. If I were to start at the initial side, just like this in standard position, but if I were to open the opposite direction going this way, I have just opened 90 degrees, but I've opened the other direction. So that means that I have a negative 90-degree angle. Same exact thing is going to happen every time we go around the circle. We're just basically opening in a negative direction instead of a positive direction. So we know that we have a bunch of different ways that we can name our angles. So degrees, we know how to deal with those because it's in regular, normal form, okay? Radians is where it gets a little bit challenging. So degrees, we shouldn't have to spend too much time talking about, but when we start dealing with radians, this is where our lives get a little bit trickier. If you don't remember this stuff from yesterday or from last year, then this is going to be a lot trickier because we actually spent quite a bit of time talking about radians. Now remember, with a radian, we are talking about the circumference of a circle. That's really what this is broken into. Degrees are broken down into 360 pieces of the circle, and every time we open an angle, we are taking 90 degrees, which 90 out of 360 is 1/4 of the circle. 180 degrees is half of the circle. 270 is 3/4 of the circle. They're broken into quadrants, right? So when we deal with radians, radians is talking about the circumference, all the distance around. But when you think about circumference, circumference is given by 2 times pi times r, right? And if my if this is a unit circle, this starts at the origin, and then this point over here, if we start dealing in our coordinate plane, is the point 1, 0. My radius of this circle is 1, which means that my circumference is going to be 2 pi. So I have to think about this circle as 2 pi for its entire way around. So the way that I break that down is, again, if I have an initial side from here to here, if I think about this in terms of parts of the circle, if I go halfway around the circle, that's just pi, right? Because half of 2 pi is just pi. If I go halfway in between 0 and pi, that's pi over 2. If I go all the way to here, this is going to be, so we go pi over 2, 2 pi over 2, 3 pi over 2. And then when we get to here, it would be 4 pi over 2, which would be the same thing as 2 pi, which is a full rotation. So when you deal with radians, that's what it looks like. So we are breaking this down into pieces of pi. So this being said, there's 2 pieces of pi right here. So it's 1 pi over 2, 2 pi over 2. That means we're taking the full 2 pi over 2 here. Okay. So all of this is just being broken down. When you deal with radians, it gets to be a little bit tricky because with radians, you're going to have to kind of sketch those things to understand what it looks like. Okay. So you're going to have to understand how to kind of sketch these things and break them down. So like if I'm asking you to sketch let me draw a circle here for a second. If I'm asking you to sketch something like, where is 3 pi over 5? This number on the bottom tells you how many pieces on top. So that tells you how many pieces are going to be on top of the circle. So again, if I break this down, I'm going to try to use this to make it easier. If I look at just breaking this in half, oops, that's not what I want. If I look at just breaking this circle in half, I know that no matter what I do, the right side of this is going to be 0. And I know that this side is going to be pi. But in this case, I want to break it into pieces of 5. So I could really write it, if I wanted to, as 5 pi over 5. So I could really break it down like that. This means that I have to count 5 total pieces of pi up here before I get to the end. So I'm just going to break this down into 5 pieces. So I'm going to have 1 piece, 2 piece, 3 pieces, and then there's my 4 and 5. I can't draw that. I can try to draw that any better, I guess. Might be easier with a mouse. So if I break this into pieces of 5, so maybe there's 1, 2, 3, 4, 5. So now I could graph 3 pi over 5 just by counting pieces of pi. So this would be 1 piece, this would be 2 pieces, this would be 3 pieces. So my 3 pi over 3 would be located right here. This is where my 3 pi over 5 would be. So radians are a little bit trickier. You have to try to break your circle into pieces of pi. Okay? So that's kind of what you need to think about. So when you're dealing with radians, when you're dealing with those things, you have to be able to go through all of those different ideas. Okay? So I'm going to, I know that's a lot of notes and a lot of talking on the first time of virtual day. So I'm going to look to see what questions are okay. I'm going to write them on the screen so that you can see them, and then I'm going to update them on Google Classroom so that way you can look at those. So give me 1 second. So what I want you to look at is I want you to look at questions 11 through 16. This is on page 572. So I want you to look at 11 through 16 because that could be okay. I want you to look at like 17 through 26. So actually, I guess 11 through 26 are good numbers. So I want you to just check those things. We haven't really talked about coterminal angles yet, but I'm sure that you could kind of think about numbers 27 through 30. I also think that you guys could look at, because you already know degrees, we didn't really talk about degrees today, but I also think that you guys could probably think about numbers 35 through 40, because those are like estimations. So I think that you guys would be able to handle all of these questions right here. Now, I obviously didn't get through as much as I wanted to today because, you know, we're still learning as we're going, but I want you to try those questions on page 572. I will update Google Classroom. I will also upload this video, so that way if you have any questions, we can talk about them. And that's pretty much, I'm going to stop recording here.